Hey viewers, welcome back to our channel. Hope you are doing extremely well. So today we are going to discuss another interesting question on the topic of try, that is nothing but maximum XOR of two numbers in an array. So without wasting time, let's move on to the question and let's try to understand it. Okay, so in this question, if I talk about the input, we are provided with an array or an array list, or we can say the vector. Okay, vector of some integer value. Okay, so here I'm taking as 2, 8, 2 and 10, 8, 2 and 10. And what we need to find from this values are, we just need to find a pair of the integer values whose XOR value is actually the maximum. So there may be possibility you are not getting the problem statement. So let's try to break it out and let's try to understand it. Okay, so the first thing is that we need to find the unique pairs from this unique pair from this vector, that is 8, 8. This is one of the unique pair. Similarly, this 8 and 2, this is the unique pair. 8 and 10 unique pair. 2 and 2 unique pair. 2, 10, and at last 10 and 10. This is also the unique pair. Now let's discuss the XOR values of 8 and 8, that is 0. Similarly, XOR of 10 and 10, this is 0. 10 and 10. 8 and 2, 8 and 2 is nothing but 10. 8 and 10, what is the XOR of 8 and 10? That is 2. 2 and 2, 0, and 2 and 10. 2 and 10 is nothing but 8. So these are the XOR values of each and every pair. Now what we need to do in this question is that we just need to print the maximum XOR value of any of the pair of the unique values. Okay, now the first thing is that you might be thinking that why I have not included 2 and 8 as one of my pair. Similarly, why I have not included 10 and 2 as one of my pair. Just because these values get repeated. Okay, if I perform the XOR operation, then the XOR between 10 and 2 and 2 and 10 are actually the same. So that's why we are not considering those values. Okay, now what we need to print is let's discuss the print. Okay, so output format, that is we just need to print a single integer value, that is nothing but this maximum XOR value. So this is the problem statement. Let's try to understand one more thing, one more test case, that is nothing but I'm considering here the values, that is the 3, 5, 25 and 2 and 8. So what we need to do in this question also is that we just need to find a pair whose XOR value is actually the maximum among all the other pairs XOR value, that is 2 and 25. So when I perform that XOR operation between 5 and 25, the value which I get is 28, and this value is actually the maximum value from all the other pairs XOR. Okay, from all the other pairs XOR. Now you might be thinking that why this is the maximum value, there definitely be other XOR pair whose XOR value can be maximum. Then I will say that no, the XOR value of both of these values are maximum among all the other pairs. So this is the problem statement. Now it's my humble request that you please pause this video right now and then try to solve this question by yourself, and after that was the solution part. So I am assuming that you have tried by yourself. Now let's try to figure out the solution approach. The first new approach of solving this question, it is using the two nested loop. Okay, and definitely this idea might come to your mind. Okay, and even you have tried this idea. Okay, so what you have done, you have used the first loop for the iteration and similarly the second loop for the iteration, and each time you are going to select a pair and then calculate the XOR between both of these values. Okay, and you are going to store it in some other variable that I'm assuming it as a max, and each time updating the max value with the maximum XOR value. This idea is perfect for the small test case. It works fine. Okay, it works fine, but the question that we are discussing right now is actually a try question, and when you going to solve when you go and try to solve this question by the approach that I discussed right now, that is the nested loop approach, then this then all your test cases will not pass. Why? Just because particularly in this question, it is expected that you only try to solve this question by a try concept. Okay, and not by the nested loop concept. That's why the input test cases are very big. When you go and try to use a nested loop on those values, there will be a time limit exceeded error on your screen. So let's discuss the another approach of solving this question, which I'm already saying, that is the try approach. Okay, so before moving on to the try approach, before directly moving on to the intuition of this question, what we are going to do, we are just going uh, to understand this concept a step by step. So the first step is understanding the XOR. Okay, like here we are saying that we are trying to find the maximum value among the XOR value. So let the first thing is how the XOR works. Let's try to understand it. Okay, we know that we have already studied the XOR in the digital electronic subject, and it is nothing but a gate, and it has some features. Okay, some features in a way that it gets some input and it shows some output, and the output will depend on that particular input format. Okay, that is 0 1 0. Similarly, I'm not assuming actually, the property of this XOR says that when I get both the value as low as an input, that is 0 and 0, then I will give the low value. Similarly, if I get both the values as high, that is 1 and 1 as an input, then I show plus 0 as a, that is the low value as an output. So the property of XOR says that if both the values are low and if both the values are high, then I show the low value, that is the 0. But if one of the value is high and one of the value is low, then I print 1 and 1. So we already know this. Okay, this is not as much important, but the important part is that understanding how this concept actually help us to get the maximum value. How this concept actually helps us to get the maximum XOR value. Okay, maximum XOR value. So let's try to understand what is the maximum value. So we know that the we already know that the integer value in annual, like I am assuming the integer value is of 4 byte, and most of the compiler declare 4 byte and a byte of memory for the integer value. It is not a new thing. Okay, so what the 4 byte has 32 bits. Okay, now what if I say that what is the 32-bit maximum number, then you will say that I'll do nothing, I'll just put 1 among all these 32 bits. You will say that I just put 1 among all those 32 bits, and the number which I get is nothing but the maximum number of the 32-bit number. It is just same as I'm asking for the 3-digit maximum number, then you will say that I just write 39 and this will be the maximum 3-digit maximum number. Now you might be thinking that why we are putting here the 1, just because when we start talking about the bit, generally we start dealing with the binary data. Okay, and the binary data only consists 0 or 1. Okay, and just to show the maximum value, I have written here the 1. Okay, so you know that the maximum value is nothing but whatever be the number of bits we are provided, we just put 1 into all those bits and we just get the maximum value. Now let's try to understand with another example. The whatever we have done till now, like whatever the problem discussion we have done till now, what we are going to do, we are just going to try to solve it in a little deeper concept. Okay, so what I'm going to do here, I'm just going to write some binary data. Okay, we already know that the input format is nothing but a decimal number. When we perform the XOR operation, definitely XOR operation performs it in the binary like performs the XOR operation in the binary format. But now what we are going to do is that for the better understanding of this question, we are just going to dry run this problem into the binary data. Okay, so I'm just going to write here some of the random binary digits. So assuming 0 0 0 1 0, this is one of the binary number. The second binary number is 0 1 1 2 3 0, and third number is 1 1 2 3, this third number, and 1 0 0 1 0, this is the fourth number. Similarly 1 0 1 0 0, this is the fifth number, and this is also one of the numbers 0 0 1 0 1. This is also one of the binary digit number. Actually if I talk about the input, then within the input you get the decimal number only. But for the better understanding, okay, for the approach of the try, what we are going to do, we are just assuming that as an input we get the binary digit, and we only need to work on the binary number. So I'm assuming what according to the question, if I use the nested loop approach, what I'll do, like I am finding the maximum XOR. Obviously the question is that, what I'll do, I'll pick that number, I'll find the XOR with all the other numbers and find the maximum XOR, and I just update in some of the variables. Similarly, then I choose this number and then I will perform XOR, then the remaining number, accepting this. Okay, accept this number, I choose this number and perform XOR with all these numbers. Similarly, I update the max with the previous XOR and the new XOR. Similarly, I did this for I do this. I do the same for this number also, do the same for this number also. Similarly for this and this also. Okay, I hope you get that what was our approach, which we were earlier, which we were doing earlier. Okay, but now what will be my approach is that, what I'm going to do is that I'm going to find the number. This time I'm going to find the pair from all of these numbers. I'm going to find the pair among all these numbers. So let's choose this number. Okay, I have choose this 0 0 1 0 1. You already know that to find the XOR of two numbers, we have to select the two pairs, but here I have selected this one. Now I'm not going to perform the XOR with the remaining numbers. This time what I'm going to do, I'm going to actually find that number, particularly that number whose XOR with that number actually the maximum value among all the other values. Okay, so how will I find? I'm assuming that that number is nothing but the X. Okay, so here I'm writing it at X. So according to my concept, what I'll do, my faith is that when I perform XOR between this X and this number, when I perform XOR between both of these, I will get nothing but a maximum number. This is my faith, and I'll solve this question with the same faith. Okay, and what was my faith? My faith is that the number is X, and the moment I perform XOR between that number X and this number is X, is nothing but selected from among all these values. Okay, definitely we will try to figure out how we will try to find this number X from these numbers, but right now I am assuming that I have selected a random number X from the remaining numbers, and when I perform this XOR between this X and the first selected number, I'll get nothing but a maximum number, the 5-digit maximum bit number. So what is the 5-bit maximum number? That is nothing but 5 times 1. We already know that why it is maximum. Okay, so this is the maximum number. Now according to our XOR concept, what the XOR says, just that if you want to get the 1 as an output, there may be two input, that is one low and one high. Okay, so as there is 0 that is mentioned here, that means definitely in the other number there should be 1. Okay, otherwise I can't get here 1 as an output. Okay, so here you can see that I'm assuming like I'm taking a back step. Okay, I'm taking a reverse approach of finding the number X. Here I have hypothetically imagined that for this particular number 100101, I'm assuming that I am trying to find out a number X from the remaining numbers when I perform the XOR between that newly finded value and the old selected value. When I perform XOR between both of these value, I get nothing but a maximum 5-digit bit number, and that 5-bit number is nothing but 11111. Similarly, now what I'm going to do is that, taking the reverse approach, now I'm finding that X, that is the value which I have selected from the remaining values. So as I know that here I have chosen the 1, as here I have chosen means here just to get the 1 here in the X, the 1 need to be present. Okay, it need to be present. Similarly, moving forward, here the 0 is present. Okay, so the moment I come to know that 1 need to be present here, then here we can figure it out that how many numbers in our all the numbers are there which can be the active candidate to be that number X. So here I come to know that these 1 2 3, actually it was 0. Wait, this number was 0, so it actually get rough. Yeah, so what are the active candidates now? So the active candidates are nothing but these force values are the active candidates. Let me Okay, these numbers are the active candidates. Let me now let's move forward. As these numbers are the active candidate to become an X, moving forward, here I get the, here I get moving forward, here I get the 0. Now according to my same approach, here I'm assuming just to get the 1 as an output, there need to be two values. One need to be high and other need to be low. But the number I have chosen at that particular position, at that number, the value is low. That means the number which I'm finding, among the remaining values at that position, within that number it need to be high. But the moment I start finding that number, I come to know that there is no high value particularly at that position. Okay, if I come to know about if we reach to a position where there is no high value or there is no such value lies within the remaining values, what I'll do, I'll just overlook that value. Okay, I'm just ignore that particular position. Why I'll just do it? Just because the maximum number which I've assumed that I'm trying to find is actually an hypothetical number. This is not a real number, because after finding the value of x, when I perform the XOR operation between the this x and this selected value, definitely I will not get particularly this as an output. Definitely my actual maximum XOR value will be nothing. Okay, will not be nothing, actually will be something else. Okay, the maximum XOR between this x and this selected value will be something else, and I have hypothetically imagined that my value, that is maximum value, is this. Now moving forward, okay, so the moment I come to know that within the selected values there is no such value present which I'm finding, what I'll do, I'll just overlook at that value and I'll just ignore that position. So here I'm assuming that as there is no such one present, so what I'll do, I'll just add the 0 here. Okay, and overlook this value. Now moving forward, here the value is 1. Like within the hypothetical, like I am trying to find the maximum number, and for the maximum number at that particular position, the 1 need to be present, and the number that I have selected, and within that number the 1 is already present at that position. So that means the other input need to be present as 0. Means at this position I need to find the 0. I just want the 0. So when I try to start figure out whether at that position the 0 is present or not among all the remaining values, I just come to know that there is 0 present but on the 3 values, but one of the fourth active candidate is nothing, is have the 1 at that particular position. So what I'll do, I'll just remove that value from my active candidate position. So this value actually get removed out from the active candidate position. Okay, now what happened, the 3 values are actually left out, and here I'm adding the 1. Sorry, actually here I am adding the 0. Similarly, moving forward, just to get the maximum value here, I just want the 1 in my final output. But the number I have selected, within that number at that particular position, the 0 is present. So what I want in my number x at that particular position, I just want 1 in my that number. So what I'll do, I just try to find out whether at that particular position 1 is present or not. And the moment when I start searching, I just come to know there is actually only a single value within all these values, that is the remaining value, in which 1 is present at that particular position. So what I'll do, I'll just select that value and discard the other values. So both of the two remaining values will get out of my out as a active candidate from this active candidate position, and the number which is 10010 will become my maximum value, maximum value among all the values. Now what was my faith? Now let's try to figure out how this approach helped me to get the answer and less time complexity. Okay, so earlier what I was doing, earlier I was finding the other pair. Obviously, here also I'm just trying to find out the other pair, but on a reverse approach. What is my reverse approach is that I'm assuming that definitely I try to find out the maximum maximum XOR value. Now the moment I select any of the value from the provided value, that is the moment I select any of the value, just here I have selected this value. Okay, what I'll do, I'll try to find out the maximum XOR value, and the maximum XOR value is nothing but the 5 bit that is the 5 times 1. Okay, obviously the 5-bit maximum number is 5 times 1. So I have I have hypothetically assumed that this is the maximum number, and now what I'm trying to do is that I'm just trying to find the x, so that when I perform the XOR between that particular x and that the randomly, not the randomly, that selected value, I just get the maximum XOR value. And while finding the value of x, there are some cases which I encountered. What was the case? The case was uh, there may be a cases, means there will be a time when I don't get the actual value which will be present among the remaining values. Okay, means when just to get the maximum value here, I just want 1, but in my all the remaining values, there is no such value, which is present, in which at that particular position 1 is present. So what I'll do, I'll just ignore those positions. Why I just do this? I just do this because the maximum number which we have selected here is actually a hypothetical number. But when I perform the XOR between the actual selected between the actual number and the between the selected number and the actual value of x, when I perform XOR between both of this value, my maximum value is actually something different from very different from this hypothetically selected value. Okay, so this is my reverse approach. This time I'm not going to find the maximum value. I'm assuming that this is my maximum value, and this maximum value is nothing but hypothetically assumed as a maximum value. That is nothing but 5 times, or means if I talk about the 4 byte, that is the 32 times 1. There's a maximum value of 4 byte number. This is a maximum value, and what I'm going to do, I'm just try to find out another value of a pair. When I perform the XOR between that value between those pairs, I'm just trying to get the same value which I have hypothetically assumed. Okay, so this is the approach which we are going to use here. Now what I'm going to do, I'm going to explain you by a try concept. Means right now what we are going to do is that we are just going to we just try to understand this whole concept by using a try. Okay, now I will create a try of these values and try to understand it how our code or how our solution will work on the try. Till now what we have discussed is the approach, and now what we are going to do is that a dry run. Okay, like how our code or how our approach will actually work on a try. So let's try to understand it, and let me remove for that. Now here also my values will remain same. That will be nothing but 0 0 0 1 0, and the another value will be nothing but 0 1 0 0. The third value is this, and 0 0 1 0 0 1 0 0, and 1 1 2 3 4, and 0 0 1 0 1. These are the values. Now let me create a try for these values. Now now while creating a try, what will be the base means the initial value of the try? Like we are dealing with a binary data, and the binary data have two active values, that is either is the 0 and either is the 1. So here also we'll take the two branches of the try, that is the we are going to create a binary try, that is nothing. Here we'll take the 0, here we take the 1. Now let's try to plot these values, all these values, by using this try. The moment we get this value, what we are going to do, we just try to create a try of that value. Here we get the 0. Okay, we reach to this side, and one more 0, one more 0. Now we get 1 and one more 0. Okay, we have created this try. Moving forward, here also we get the 0, but the second value is nothing but 1. So let's move forward. After 1 there is 0, there is 0, and there is 0. 3 zeros. Moving forward, here is the first, or the initial value is nothing but 1. There is single 1, and the all the other remaining value is nothing but 0. So that is the 4 0. Let's try to plot this. Here at first we get this 1. After this 1 there is 0, so we move here, there is 0. We move here, there is 1, but there is no 1, that is the 0 is present here. So we need to create a branch of this. So we move here, and at last we plot this 0 here. Again here there is 1 0. The moment we reach here, that is 0, the next element, that at the next position, the 1 is present in our provided element, but within our try there is a 0. So what we'll do, we just create a new branch and put 1 here. Moving forward, we put 0 here, 0 here, and we get 1 0 1 0 0. Similarly 1 present here. Okay, it was both of this number will become same, and it was, I'm putting here 1. Okay, now let's try to plot them again, and here it was 1 0 0 0. Now this will become 0. This number I have plotted, this number. Now let's try to plot this number 0 0 1 0 and 1. This will become our try. Okay, this will become our try. So let me decrease its size. So we have created this try. Okay, now what we are going to do is that each time we select a single value from the provided values. Okay, and for that provided values we try to figure out the value of x. What will be the value of x? That is, the value of the x is nothing. So let's try to understand it. Okay, we have selected this value 0 0 1 0. Okay, it was the 5 bits, no? 0 0 1 0 0 0 0 1 0 0 0 0 1 0. Okay, so let me write a 0 at the beginning here. 0 0 1 0 0 0 0 0 1 0. The number is same. Okay, now let's try to understand the question. What we'll do right now is that we will select the x. We will find the x hypothetically. Hypothetically means we find the x with the maximum value of the 5-bit or the 4 or the 32-bit number. Okay, we find the max x. We'll find the value of x with the maximum value, with the maximum hypothetical value. And after finding that x, what we'll do, we just try to check that whether that x can be easily extracted out from this try or not. Okay, so let's try to understand. So we have selected this value. I am assuming that I'll perform an XOR between that value and the x, and as a result I get the maximum 5-bit number. Why I'm saying the 5-bit number? Because here I'm assuming that all the values are the 5-bit. If it is a 4-byte, then there are so many zeros lying at the present before that. Okay, now let's try to figure out what will the value of x. As an output, we just want to get the 111. So as an input we just get nothing but 1 1 1 0 and 1. This can be our, okay, wait, let me remove this. Let me remove, yeah, 1 1 1 0 1. This can be one of our this can be the value of x. This is hypothetically calculated. Okay, it is not mandatory that that this value actually present on our input data set or not. There may be possibility that this value can be present or not, but what we are going to do, we are just trying to find out that is there any similar values actually present in our data, in our provided data set or not. Okay, so what we have done till now, for that value, for that selected value from the provided data, we have calculated a value of x with the concept that to get the maximum value, hypothetical maximum value, and the value which we get the x, now we are just trying to find a similar value on our try. Okay, so for that value, at first we get the 1. We reach to this 1. We check that whether any value starting with the 1 is present or not. When we get to know yes, there are so many values starting with the 1 is present, now we move forward. Okay, and we add this 1 in our answer. We move forward and we get the 1 again. Okay, now again we try to find out that whether a value at the 4th position. Why the 4th position? Because on the binary number the position start from the left, from the right hand side, that is 0 1 2 3 4. Okay, so at the 4th position, whether is there any value that is present, having the value 1 is present or not. And here we come to know that no, there is no such value present whose 4th position have the value 1. The moment we come to know there is no such value present, what we'll do, we just add the next value that is present on our try, that is nothing but 0. So we just add this 0. We move forward, we reach to this 1. Again we ask the same question, whether is there any value present having this 1 on the try or not. Okay, at the 3rd position, the moment we ask this question, we come to know that yes, we have already explored this position, we get this 1. So we add this 1 in our final answer. Moving forward, checking for this condition, checking for this position, actually we here we need to search for the 0, and here we come to know that yes, 0 is present on our try. So we add it into our result. Similarly for this one, we ask the same question, and the moment we ask this question, we come to know that one is not present on our try. But on the try, we can't backtrack just because we are finding the similar type of value. Actually, we are just trying to find out whether is there any similar type of value is present on our remaining values or not. We our goal is not to find the exactly same value, but our goal is to find the similar type of value. And the moment we ask for this zeroth index position, we just come to know that yes, there is one more value, that is having the value 0 is present. Okay, so we now we can say that the value which we have find it out till now, which we have find it out, and the final result, that is the answer, is nothing but a value of a pair whose XOR can be is the maximum XOR among all the other remaining value. This is not the only value. Okay, we perform this operation for this, for all the other remaining values. Okay, till now we have searched out for this value. Now we perform the same for this for this result also. Then we get something else. Okay, now we then we get something other pair, we calculate the XOR, we store it somewhere else, and at last we get how many XOR pairs we get. 1 2 3 4 5 6 7. At last we get the 7 XOR pairs, and from those 7 XOR pairs, what we need to do is that we just need to find out the maximum XOR. Okay, I hope you get out what I'm trying to say. What I'm trying to say, like, at first I have finded out the pair of the first pair. Now we are going to find the second pair including this value. After that, we are going to find the third pair including this value. Then we find this fourth pair including this fourth value. Then fifth pair including fifth value, sixth pair including sixth value, seventh pair including the seventh value. And the moment we get all the seven XOR values, we'll find the maximum. We find the XOR among all those 7 values. Okay. So one more thing which I want to say is that I'm not going to explain the deep concept of the bit manipulation, because I'm assuming that right now we are on the level 2 and you have already completed your bit manipulations series. Okay, so, and you have already solved the question on that, so I'm assuming that you already know how can we easily extract that a particular bit position. Okay, how can we extract at that position value from this particular number, and how we update that particular value at that particular position. Okay, definitely we use the mask when we perform our operation with that mask. We update that value and we perform, and with that mask we get that particular position value. I'm not going to explain all this thing just because explaining the bit manipulation, the concept of this question and the code of this question is too lengthy. Okay, and even I'm assuming that you already know all these things. So I hope till now you get the concept of this question. Now what we are going to do, we just move on to the Pepcoding portal and write the code of it. Okay, so this is a Pepcoding portal. Now let's try to write the code here. Okay, so here, okay, let me take it to this side. Now what we need to write, we just need to complete this find maximum or function, and it have a parameter of the num vector, and it has the values within which we need to find the pair and the maximum XOR value. So what at first what we'll do, we just write the abstract code. Okay, we just assume that there are functions which we are going to use here are already present, and their code are already written, and they are perfectly working. Okay, and at last what we'll do, we just complete the code of those functions. So at first I'm just creating a object of the try class, new try. I'm assuming that this class is already created upper here. Okay, and we will soon create it for int val and nums. Now what I'm going to do is that I'm just going to create a try for all those values. I'm just going to map the values of the nums into the try. So for int val try and try insert, I'm going to insert the value into that and I'm assuming that this insert function will work fine, and it is suitable enough to create that. It is strong enough to create this try. Okay, so moving forward, like I'm assuming our try is already created. There is a variable max I which actually stores our final maximum XOR value. So moving forward, what we need to do, one by one we are just going to select one each value each value, and then we find the value of x. And after finding the value of x, what we'll do, we just check that whether is there any value in our all the remaining values, is there any value exists which is actually similar to the, whose value is actually similar to the value of the x. Okay, so int val nums, what I'm going to do, I'm just going to select each value one by one. At first I'm just going to find the find the value of x, and how I will find the value of x, soon I will explain it. Okay, so well, after that I will check that whether is there any value exists in the remaining value of the nums, which is actually similar to the value of this find. So let me find it. There is a method query which is strong enough to find that value on the try. So find, okay, find, and when I get that value in the resultant, I just need to find the maximum value between the maxi and the resultant value, and the val and XOR of val and resultant value. So when this when we completed this code, we just need to return the maximum value which actually get printed out here. Now let's try to understand what I've written here. So this is the first line of code, which is actually quite confusing. Let's try to understand. We know that A XOR B is C. A and B are the random values, anything can be. C is a random value. Just to find out the A, can I write the code like this? C XOR B is already also the A. Like I know the value of C and B, and I am performing the XOR of it, and here I'm getting the value of A. This is a property and it actually works. Okay, so the same thing I'm going to write it here. I know that my int max is the maximum value of the of the integer data type. So I'm assuming that here is the int max, and here is the value which I have selected, and it is stored in the val, and I am trying to find out the x. Just to find the x, I have performed the XOR of this, and the XOR of this is nothing but this x. Okay, so within this find, I find out for this is my first step, just finding out the x. Now moving to the resultant function. What is this resultant function? Is this x that I have find it out is the actual value of the x? Is the actual second value of the pair? No, this x is actually a hypothetical value, which is actually calculated by a faith that that our XOR between the x and value give us the maximum integer value. Okay, and this int max is also an hypothetical value, just because I have assumed it that when I perform the when I perform the XOR between two values, I get the maximum integer value. This is my faith, okay, the concept which I've used, and I've already explained it to you. But now what I need to do, I just need to find out a similar value from the values which I have provided in the nums vector. So what I'll do for that, I'm just passing this x as a parameter to the query function. What this query function does, it just go and find out the similar value on the try. Okay, and the moment I get this value into the resultant variable, I just find the maximum value between the val dot maximum, that is the previous maximum, and the XOR of val and res. Why val and res? Just because we need to find the resultant value. The val is the selected value from the nums, and res is the finded value from the try. So that's all what I have written till now. So let me erase it and let's complete the other code. So till now I've assumed that I have completed the abstract code. Now let's complete the full code and create this function query insert and the class try. So at first what we will do, we just create the class try. So class try, and it will take some parameter. Okay, let me, so class node, here I'm creating one more class, that is the node. Why I'm creating it? Just because our try looks like a binary tree, means it has only two values. The one is the left value, that is the 0, and one is the right value, that is the 1. That's why I'm going to create it like a binary tree. That is, it will have two pairs, it will have two children, that is nothing but node star left and node star right. Okay, node star left and node star right. So let me close this class. Moving forward, let me create the object of this class. Node star root equals to new, no, sorry, and within the constructor of this try class, within the constructor of this try class, let me update this root new node. Okay, so till now I have created a try class. Now let's write the function of void insert. Now let's create the try using the void insert function, void insert, and it will take the value as a parameter. Now now I'm going to write some code, and after writing that code I will explain you that what this code is actually doing. Okay, so at first I'll get int bit index equals to 30. Why I've selected it as the particular 30, I'll soon explain to you. Okay, and again node star current equals to root. Now while bit bit index is greater than equals to 30. Okay, so int, let me create the mask. The mask will be nothing, one left bit index, and after that let me get that particular bit. To get the particular bit, I need to perform the and between mask and val. If that value is greater than 0, get 1, otherwise I get the 0. Now I'll check if bit is 0. If it is 0, I'll perform some task, otherwise I'll perform some task. Okay, so what will task? We'll soon figure it out. So let me explain the code that I've written till now. The first thing that what I've explained, what I've assumed is that the integer is of 4 byte. Okay, so for the 4 byte integer I get 32 bits, and the 1 bit is actually the sign bit. That is the first, the leftmost bit. Okay, or I can say the most significant bit. So so for that I get the 30 bit, and just to get the maximum value of the 30 bit I can put here the 1 on all those bits. Okay, so that's why here I am iterating over only this 30 bits. Now nodes are current. Here I'm creating a reference to that to that try. Now I'm creating the mask. Now I'm creating a mask just to, okay, yeah, I know that there are 30 bits, and I just need to work on a position, each and every position of that bit. Okay, so just to get that particular position I have created here a mask. If you have completed the bit manipulation series, then definitely you know what this mask actually done. And if you haven't done this, then please go and watch that, or please solve all those questions. Okay, you already know what this mask done. Okay, I have created this mask. Now after creating the mask, I'm just getting that particular position value. Okay, what is the value at that particular position? Okay, by this and after getting that value, if the value is 0, I'll do something, that is I'll check if current left is null pointer. If this is the case, if current left is a null pointer, then what I'll do, I'll create a new node. Otherwise what I'll do, I'll just current equals to current left. Similarly here also I'll do the same thing. I'll check if current right is a null pointer. If this is the case, then write current right equals to new node. Otherwise current equals to current right. And at last I just need to decrement the value of bit index. Bit index. Okay, this is the code. Now what I'm doing, if I get the bit as a 0, what I'm moving to the left hand side and creating a node there, and if the value is 1, I'm moving to the right hand side and creating a node there. This is the void insert function. Now let's move on to the query function, and what this query function does actually, here what this query function does, it actually check that whether is there any similar variable, which is there any similar value which lies on the try. So int ry, int query, int find. So at first I'll just create int bit index. Here also the bit index will remain the value as 30. Now moving forward, node star current will be root. creating the reference of a try. Now int answer equals to 0, and this will contain my answer. Okay, now while bit index, bit and the value of bit index is greater than equals to 0, till then I just need to iterate over my value. Now here also at first I need to create the mask. I need to create the mask first. Mask will be 1 bit index 1, actually not the I, 1 bit index. Okay, fine. Moving forward, after mask, here I get the bit at that particular position. The bit is find and mask. If it is greater than 0, here I get the 1, otherwise I get the 0. Okay, if it is greater than 0, the 1, otherwise I get the 0. Now I'll check if that bit is 0 or not. If that bit is 0, I'll do something, I'll do some task, otherwise I'll do some task. So till now I've written the same type of code. I've iterating over the 30 bits, and just to get the each and every position, just to get the bit at each and every position, what I'm doing, I'm just creating a mask. Okay, and after that, just to get that just to get that at positional bit, I am performing AND operation with this with a find, with a mask. Okay, or that value and the mask. Now here I'm writing the code between the for the particular cases, that is if bit is 0, I'll check if current left is not equals to null pointer. If it is not null pointer, I'll just move over the left hand side, current equals to current left. Otherwise what I'll do, I need to add, okay, let me move that value, current equals to current's right, and let me add that value, add that bit value to my answer. Okay, so answer equals to mask. So let me write the same type of code onto the else part also, but for the, okay, control C, control V here. But for the right hand case, if current right is null pointer, what I'll do, I'll just this time here I need to update, move to the right hand side, current's right, and answer or equals to mask. Otherwise I just need to move toward the left hand side. No, okay, otherwise I just need to move towards the left hand side, okay. So this is the code, and after this else I just need to, each time I just need to decrement the bit index. Why I need to decrement the bit index? Just because I'm operating for each and every positional bit, that's why I need to decrement it, and at last just return our answer. Here we are returning our answer, that is the return answer. So this is the code. Let's try to run it, and if we encounter any of the error, we will try to figure it out. And till then, so let's try to run it. And yeah, here we are getting the error, return answer, I think. Yeah, so at the line 73 there is a problem. Okay, we forget to close the class, and here we are getting some error, that is current left equals to the next pointer. Let's try to figure it out. Declared private here. Okay, I forget to make them public because I can't access the private members. Okay, segmentation fold. Let's try to figure out why I'm getting this. Okay, so we are getting this error just because here I have written the bit index is greater than equals to 30, but that was a wrong condition. Okay, this condition can never be encountered, so our code is accepted. Let's try to submit it for all the test cases, and most probably it will work. and yeah, it is working. So I hope you get the concept of this video, you get the solution part and the intuition of this question, and you know, and you get now you can figure out that why the previous approach, that of the nested loop approach, is not suitable for this particular question, and why this try concept is better for this question or for this type of question. So that's all for this video. Let's meet in the next video. Till then, stay safe, stay healthy, and if you like the content of this video, don't forget to hit the like button and subscribe to our YouTube channel. So till then, stay safe, stay healthy.